Okay, hi guys, so in this lecture we'll be seeing the test of nitrite salts. So let's get started. So we'll be seeing test of nitrite salt, which is NO2 minus ions. Okay, so all nitrite salts are water soluble except nitrite salt of Ag, Hg and Cu. So we can write that all nitrite salts are water soluble except nitrite salt of Ag plus, Hg22 plus and Cu plus. So if we look at the reactions of the same, then again let's start. We have NO2 minus ion. Okay, first it is subjected to test based on reducing property. Okay, so reducing agents, we can have other oxidizing agents. We have Cr2O7 2 minus aqueous. In H plus we can also have MnO4 minus. In H plus we can have Br2 water. So this gives us NO3 minus aqueous and green coloration due to presence of Cr plus 3 and etc. whatever we take. Okay, so this is green coloration in case Cr plus 3 is formed. Next, when we react it with, or rather we can say that test with dilute HCl, we can also have dilute H2SO4, which is again a salt decomposition reaction takes place. Okay, so we get HNO2, which is less stable, and upon warming the solution we get NO plus HNO3. Okay, and this NO, when is passed in air or is subjected to air, converts into brown colored NO2 gas. Okay, next we react NO2 minus ion with a strong reducing agent. H is a strong reducing agent, so nascent hydrogen, so it converts into a basic gas, which is NH3. NH3 is a basic gas. Okay, and this NH3 gas, on passing through Nessler's reagent, Nessler's reagent is nothing but K2Hg I4 plus OH minus. So we get HgO dot Hg NH2 I. This is a brown PPT. Okay, so this is called basic amido mercuric iodide. The name of this brown PPT is basic amido mercuric iodide. Okay, next we see the reaction of NO2 minus ion. Next, let's say we have a specific test of NO2 minus. Okay, so in which we have a brown ring test. Okay, brown ring test. So we have a vessel containing, let's say a beaker containing FeSO4 and also contains NO2 minus ion. Okay, so from into this beaker we are pouring, this is a bottle of dilute H2SO4. So we are pouring dilute H2SO4 into a vessel which contains FeSO4 and NO2 minus ion. So we get a brown ring formed. Okay, so the NO2 minus gives brown ring test. Okay, next, actually when we treat this NH3 basic gas with HCl, what we see is a brown white dense fumes of NH4Cl. We get white dense fumes of NH4Cl. Okay, next what we have is, suppose we are testing it with AgNO3 solution. Okay, so we get a ppt of AgNO2, which is a white ppt, okay, which is soluble in dilute HNO3 and complexing agents. Soluble in dilute HNO3 and complex agents. Or other complexing agents. Okay, next let us discuss the specific test of NO2 minus more. So when freshly prepared solution of FeSO4 which is oxidized by air on longer duration, solution is added to the soda extract followed by the addition of soda extract, we mean NO2 minus ion. So when FeSO4 and NO2 minus ion containing salt are mixed, and by the further addition of dilute H2SO4 by the side wall of H2SO4, rather side wall of the test tube, this is the test tube, with the help of a glass rod. We can also have a glass rod inserted here. Okay, this is the glass rod. Okay, so if brown ring is formed at the junction of the two liquids, then NO2 minus radical is confirmed. Okay, if we get this brown ring formed, then NO2 minus is confirmed. Let us see the reactions involved in the specific test. So in this specific test we have NO2 minus aqueous solution reacting with H plus from dilute H2SO4. So this undergoes salt decomposition and it forms HNO2, okay, which is less soluble. Okay, so we get from this HNO2 NO plus HNO3, and this NO when treated with this complex reagent FeH2O whole 6 SO4, it forms brown ring complex. By the way, FeSO4 is a good absorber of NO gas, is a good absorber of NO gas. Okay, so we get Fe H2O whole 5 NO and SO4. Okay, so this is a brown ring complex. Next, let us see some of the limitations of the ring test. So aqueous solution of MnO3 whole twice or MnO2 whole twice. So let me rewrite it or simply write it. Limitation of ring test is that aqueous solution of MnO3 whole twice or MnO2 whole twice, where M plus can be equals to Ba plus 2, Sr plus 2 or Pb plus 2, NO3 minus, does not respond to Brown ring test because does not respond to Brown ring test because these cations form insoluble sulfate salts with H2SO4 okay, and usually in ring test formation the PPT formation will occur, or rather will create turbulence in solution, and then in ring formation, rather in ring test, formation of PPT or precipitation will create turbulence in the solution. Okay, so therefore Brown ring complex is not formed. Okay, so with this we come to the end of this lecture. We'll be continuing on seeing more on the same in the next lecture. So till then, good luck and goodbye.